Hello, good student. Welcome to Makali Digital School. Today we are going to dive moles, and the subtopic is titration. Titration. So in titration, we have three parts of titration: the direct titration, the back titration, the direct titration, the back titration, and the redox titration. Redox titration. We have that three titration. So in titration, in exam, it is tested in two ways because in Macleay tuition, we only focus on three things. Number one is what is tested, how is tested, and how is answered. That's the three things uh, that is focus of Macleay Digital School. Type of titration, to start with the direct titration, then followed by back titration, then we will go into the redox titration. Let's start. Before I start, I want to start from very important formulas that we're going to use. The constant formulas that we use in moles. Number one is the moles. Moles is equals to mass over RAM. That's number one. Number two, moles is equals to molarity. Moles is equals to molarity. Moles is equals to molarity times volume over 1000. Hiyo ni ya pili. Number three is concentration is equals to molarity times molar mass. Molarity times molar mass. In case of you don't see whatever I have written, you can write whatever that I am saying. Molarity times molar mass. Number four is percentage purity is equals to mass reacted divided by total mass. There is another formula for dilution. M1V1 is equals to M2V2, but that one we are not looking. So that's the most common formula that you are going to use. So let's start with the direct titration. Let's start with the direct titration. Let's start with the direct titration. Direct. So before we start with the direct titration, nataka mjue kitu moja. I want you to know one thing, and that is whatever that you see that anything to do with direct titration, redox, or back titration, I usually advise my student to write first thing to write the chemical formula, chemical equation, a well balanced chemical equation. The chemical equation must be balanced. Why do we require a balanced chemical equation? We need a balanced chemical equation for one reason. Number one is to get to obtain a mole ratio. To obtain the mole ratio. So let's start with this equation. Start with this. Number one, we start with this equation. The question says a given volume of 0.2 molar sodium hydroxide require exactly 20 centimeter cubic of 0.1 molar sulfuric acid for complete neutralization. Calculate the volume of the sodium hydroxide that reacted. Calculate the volume of sodium hydroxide that reacted. So in direct titration, you can be only asked in 6 ways. Number one, sometimes they may ask you to calculate the volume, like this question, the first question. Sometimes they may ask you to calculate the relative formula mass. Sometimes they may ask you to calculate the concentration of analyte. Sometimes they may ask you to calculate the percentage purity of analyte, and then sometimes they may ask you a known volume of analyte, also a known mass of analyte, also water of crystallization. So in this video, we are going to look the three main part, combined the challenging part. Number one is we are going to look the volume. That's a normal thing. Number two, we are going to look the percentage purity. And number 3, we're going to look the water of crystallization. So let's start with this. I told you, first of all, we start with writing the chemical equation, a balanced chemical equation. Balanced chemical equation. We start with balanced chemical equation. So what is, the reactant is what and what? The reactant is sodium hydroxide. Sodium hydroxide reacting with sulfuric acid, giving us, so this it make us to be back itabidi sasa turudi kwa ile topic inaitwa acid base and indicator for one work. So where acid plus base inakupatia nini? Salt plus water, inaitwa baswa. Base plus acid inakupatia salt plus water. Acid plus metal inaitwa mash. Metal plus acid, it will give you salt and hydrogen gas. So it will take us back to form one work. So sodium hydroxide is the base. Sulfuric acid is the acid. Acid plus base react to produce salt and water. That is sodium sulfate and water. Sodium sulfate and water. After that, we balance the equation. So this is 2 here, also 2 here. We balance the chemical equation. After we write the equation, then tunaandika kila moja information yake tuko nayo. The information is 0.2 molar of sodium hydroxide. Tuko na molarity 0.2 molar of sodium hydroxide. Require exactly 20 centimeter cubic. Inahitaji exactly 20 centimeter cubic of 0.1 molar sulfuric acid. So it requires 20 centimeter cubic of 0.1 molar sulfuric acid. Calculate the volume. So we finished. So kila moja information yake tumeandika chini. So tunasema aje sasa? Tunatafuta the moles of sulfuric acid. Tulisema moles kwa ile formula yetu kwa juu is equals to molarity times volume over 1000. Molarity times volume over 1000. Molarity times volume over 1000. Molarity is 0.1 times volume is 20 divided by 1000. So this will give us 0.02 mole. It will give us 0.02 mole. It will give us 0.02 mole. So we get the moles of sulfuric acid. So we want to get the moles of sodium hydroxide. So tunaandika sodium hydroxide kando. Is to sulfuric acid kando. Hizi mbili na react. So sodium hydroxide tunasema kwa balancing ya sodium hydroxide ni ngapi? Tunarudi kwa balancing. Na ilikuwa 2 na sulfuric acid ni 1. So tunarudi, hii itakuwa 2 and this will be 1. Moles ya hii ni ngapi sasa? Ya sulfuric acid ni ngapi? Ni 0.002. So we cross multiply. So the moles of sodium hydroxide will be 0.004. So we get the moles. So after that, tarudi hapa sasa kwa juu. So this will be 0.2 molarity tuko naye na tumepata moles hizi 0.004. So tunauliza nini swali na tunauliza nini? Calculate the volume. Or determine the volume. So that will be easy now. Very easy. So we just follow the formulas. Formula ilikuwa nini? Moles is equals to molarity times volume over 1000. Moles is equals to molarity times volume over 1000. Molarity is molarity is of sodium hydroxide was 0.2, I think. 0.2, yeah, 0.2. by 2 times volume tafuta over 1000 is equals to the moles tulipata saizi 0.004. So times cross multiply times 1000 over 0.2 times 1000 this side times 1000 over 0.2. So 1000, 0.2, 0.2. So unabaki na volume is equals to 1000 times 0.04 divided by tabaki 1000 times 0.04 divided by 0.02 kama hii. Unaona? So and the answer will be 20 centimeter cubic. So I think you understood for that question. Let's go to the second question. Let's go to second question, where we are going to determine achana unknown mass rahisi. I'm going to determine percentage purity. Percentage purity. Percentage purity. So listen at this question. 0.8 gram of calcium carbonate completely reacted with 50 centimeter cubic of 0.2 molar dilute hydrochloric acid. Determine the percentage purity of calcium carbonate. So 0.8 gram of impure. The calcium carbonate that we have already is impure. So that calcium carbonate reacted with 50 centimeter cubic of 0.2 molar hydrochloric acid. So what will you do? We write the equation. That's our first thing. So we write the calcium carbonate. Write the calcium carbonate. Let me write the calcium carbonate. This is the equation. This is the equation. I think unaona. Calcium carbonate plus hydrochloric acid, calcium chloride plus carboxyl plus what? Plus water. So the mole ratio, the mole ratio to be balanced. The mole ratio of calcium carbonate and hydrochloric acid is 1:2. So before that, let's write with the whatever the information that you have. In calcium carbonate and hydrochloric acid 2. I think starting to be balanced because iko hapa. So calcium carbonate is tunaandika information tuko nayo. So it reacted with 50 centimeter cubic. Reacted with 50 centimeter cubic of 0.2 molar. 0.2 molar. So what will you do? We tatafuta the moles. Moles is equals to molarity, which is 0.2 times volume, which is 50 over 1000. So we get the moles as 0.01. 0.01. So that's the moles. So we just take that, then we take the calcium carbonate, Ev, is 2 HCl. So HCl ilikuwa hapa 2, na this was 1. It's only that we don't show in chemistry. So this was 0.01. So itakuwa cross multiply. Itakuwa 0.01 times 1 divided by 2, which is equals to 0.005 moles. 0.005 moles. After that, we are going to look then the mass of calcium carbonate. Remember that the calcium carbonate that we are given initially was impure. So we are going to look the mass of the pure calcium carbonate. Mass of the pure calcium carbonate. So mass is equals to, we are going to use mass is equals to, the formula 2, mass is equals to moles times molar mass. Moles times molar mass, which is RM or RFM, molar mass. So the number of moles is 0.005 times molar mass. How can we get? We can get by doing this. We say this is calcium carbonate. you will be given, in exam you will be given. So calcium itakuwa 40, carbon ni 12, RMF ni 12, plus oxygen ni 3 times 16, I think ni 48. So 48 plus 12 plus 40, it will give you 100. So times 100. Multiply times 100. Times 100. So we'll get 0.5 gram. We'll get 0.5 gram. So before I start my lesson, there's a formula nimekuandikia, and that's the percentage purity is equals to mass reacted. So the mass reacted, the pure mass reacted is 0.5 divided by total mass, that is the impure one, 0.8 multiplied by 100%, by 100%. So after that, what will you get? 62.5%. So you'll get 62.5%. So that is direct titration. So the last part ambayo nitaangalia ni so you can do this question. You can do this question and you can give the answer to this question in the comment section. The comment section. 7.5 gram. Andika 7.5 gram. Or I can zoom for you. So 7.5 gram of impure sodium hydroxide. 7.5 gram of impure sodium hydroxide is dissolved in water and a solution made to 50 centimeter cubic. 20 centimeter cubic of this solution require 13 centimeter cubic of 1 molar dilute hydrochloric acid for complete neutralization. Determine the percentage purity of sodium hydroxide. So that answer I need it in the comment section. So this is relative formula mass. It is also a very easy part. Very easy part. So also this is very easy part. So to determine the water of crystallization, let me look question of water of crystallization. So 12.01 gram of hydrated sodium carbonate dot N water is dissolved in water and the solution made up to 500 centimeter cubic. 25 centimeter cubic of this solution require 21.2 centimeter cubic of 0.2 molar diluted hydrochloric acid for complete neutralization. Determine the value of N in the hydrated salt. Very easy. So for this question, remember that titration is all about practicals. All about practical. So you get to practically to real, practically real. For example, angalia, hii kitu already imedissolviwa in water. Imekuwa dissolviwa in water. So after imedissolviwa in water, already imedissolviwa in water, so solution sasa ikapelekwa up to, yani ilidilutiwa up to 500 centimeter cubic. So solution imepeleka already 500 centimeter cubic. Tumeelewana? 25 centimeter cubic of this solution, hiyo solution ambayo imepeleka 500 centimeter cubic, 25 centimeter cubic of it ina require 21.2 centimeter cubic of 0.2 molar dilute hydrochloric acid for complete neutralization. So what is the reaction? In the react, sodium carbonate is dissolved in water, and the solution is made up to 500 centimeter cubic. 25 centimeter cubic of this solution require dilute hydrochloric acid for complete neutralization. Determine the mass of sodium carbonate. Determine the mass of the value of N in sodium carbonate. So what's reacting is HCl and sodium is it sodium carbonate or calcium carbonate? Sodium carbonate. Yes. Sodium carbonate. So we write the equation. I don't want to repeat myself. We write the equation. Highlight. So this is the equation. This is the equation. The equation. So that is sodium carbonate plus HCl itakuwa sodium chloride plus. So, and when we are looking the mole ratio, we are not looking the product side. We are looking the reactant side. So sodium carbonate mole ratio is 1:2. So let's be back for the information and then write whatever the information that you have. That is sodium carbonate, and HCl. So this is 1 and this is the 2. So that's the mole ratio. After that, what information do we have? 25 centimeter cubic of this solution require 21.2 centimeter cubic, 21.2 centimeter cubic of 0.2 molar. So uzuri ya chemistry ni chemistry is very easy. Wanakupatia information full kwa side moja. Angalia saizi tuko na volume na tuko na molarity. Ile kitu hatuna ni gani? Moles. Na moles huwezi very obvious, lazima utafute. So after that task we're going to say moles is equals to molarity. Moles is equals to molarity, which is 0.2 times volume, which is 21.2 over 1000. So after that, I get the moles. So moles is 0. 0.002 all of moles. After that, we just return to the mole ratios. Just return to mole ratios. These are mole ratios. Just return them. So this was 1 and this was 1 and this was 2. So kama hapa sasa tumepata 0.012 itakuwaje? Divide by 2 sitakuwa sote hii itaenda hii side na hii itakuwa hivi. So itakuwa divide by 2. So after nikidivide by 2 nitapata ngapi? Nitafuta the mole ratio. So sodium carbonate, the E ni kama tu sina calculator ni vile tu nimeangalia hapa. So inafaa ikuwe 0.2 times 2 to all of hii itakuwa, hii ndio iko na error. Itakuwa 0. Hii itakuwa 0.00424. So tukidivide by 2, tukidivide by 2 inatupatia hivi sasa. I think you are understanding. E 0.2 times 21.2 divided by 1000. Divided by 1000. So divided by 1000, itatupatia 0.0424. So this since mole ratio is 1:2. 1:2, so we cross multiply. As to cross multiply tunapata ngapi? 0.0212 moles. So you get the moles of sodium carbonate. So sodium carbonate nini tuko nayo? We have its volume, because walituambia 25 centimeter cubic of this. We have its volume. We have its moles. Tulipata size 0.02. So what will you do? We're going to find the molarity. Molarity inafanywa aje? Moles is equals to molarity times volume over 1000. We make molarity the subject of the formula. And the moment we make the molarity the subject of the formula, tunapata hivi sasa. So 0.022 times 1000 divided by 25. So and we get 0.8084 moles per decameter cubic. That's the molarity. That is the molarity. So after that, we are going to look the concentration. Concentration is equal to mass times 1000 over volume, because nimekupatia huko juu the formula of the concentration, and we are going to get the 24.02 gram. So let's continue. Let's continue. After that, so and this when we are, let me clarify something here. When we are looking for concentration, we are using 500,000, 500, I mean 500 centimeter cubic because the solution was made up to 500 centimeter cubic. So after that, we say the mass is equals to mass of sodium carbonate dot water is equals to 283. After that, we equate the equation. After that, we equate highlight. After that, we equate water. So after that, we equate. How can we equate? Because we understand sodium, RM of sodium in gap is 23. 23 times 2, which is 46. Plus carbon in gap 12. Plus oxygen 16 times 3. Plus water 18. Like in N atuna 18N is equals to 283. 283. So 18N is equals to 283 minus 106. 18N is equals to 177. N is equals to 10. And that's all about direct titration. So make sure that you subscribe the channel. Before I finish my class, I want to clarify two things. I want to clarify two things. That is molarity and concentration. Molarity and concentration. Usually, molarity and concentration, watoto wana confuse sana. So let me clarify. So that's molarity and concentration. Molarity and concentration are one and the same, first of all. That's the first thing that you have to know. Molarity na concentration haina tofauti, ni one and the same. Lakini iko na tofauti moja. Hii molarity iko na moles. Iko na moles. Hii concentration iko na mass. Mass inamaanisha nini? Sasa iko na grams. So ukiona moles per liter, moles per decameter cubic, moles per deciliter cubic, that is molarity. That is molarity. Ukiona gram per liter, gram per decameter cubic, gram per deciliter cubic, that's concentration. Hazina tofauti, lakini concentration, it has gram instead of moles, and molarity has moles instead of gram, and that's the only difference that we have. So then that's our end of first lesson, that is direct titration. Then our next lesson will be back titration and redox titration. So if you have any question, you can post it in the comment section. Before I finish, I want to ask you one question. That is the formula of moles. So make sure that if you learn and understand, make sure that you write all formula of moles that I have given you earlier in the comment section, so that I know that at least the student understood and I can continue the lessons. Thank you.